For decades, Pluto was a planet. Then suddenly it wasn't. But is Pluto still a planet? For most of the 20th century, Pluto had a very simple identity. It was the 9th planet. Discovered in 1930, Pluto entered school books, maps of the solar system, documentaries, and the imagination of generations. It was the tiny, distant world at the edge of the known planetary family. Far beyond Neptune, cold, mysterious, and almost impossible to study in detail, Pluto remained a planet simply because, for decades, there was no reason to call it anything else. But then, astronomy changed. The more powerful our telescopes became, the more objects astronomers discovered beyond Neptune. Pluto was no longer alone in the darkness. It was part of a much larger region known as the Kuiper Belt, a vast population of icy worlds orbiting the Sun in the outer solar system. Suddenly, Pluto was no longer just an isolated 9th planet. It had neighbors, and some of those neighbors were surprisingly similar to it. That created a problem that astronomers had avoided for decades. If Pluto was a planet, what about the other worlds being discovered in the same region? Should they also become planets? And if so, how many planets could the solar system eventually have? Then, in 2006, the debate reached a dramatic conclusion. Pluto was no longer officially classified as a planet. It became something else, a dwarf planet. For millions of people, it felt as though Pluto had been expelled from the solar system. The familiar list of 9 planets was suddenly reduced to 8. Schoolbooks changed, arguments began, and even today, almost 2 decades later, the question still refuses to disappear. Because Pluto itself did not change, its size did not change, its mountains did not disappear, its atmosphere did not vanish. Only one thing changed: the definition of what we call a planet. And that raises a much deeper question. Did science discover that Pluto was never really a planet? Or did scientists simply change the rules and leave Pluto on the other side of the line? The story of Pluto's reclassification did not begin with Pluto itself. It began with the discovery of other worlds. For decades, Pluto appeared to be unique. It was known as a small and distant planet beyond Neptune, orbiting the Sun in a strange and highly inclined path. But as astronomers began to explore the Kuiper Belt in greater detail, they discovered that the outer solar system was far more crowded than anyone had imagined. Pluto was part of an entire population of icy bodies. Some were smaller, some were large enough to be nearly round. And then came one discovery that made the problem impossible to ignore: Eris. Eris was found in the outer solar system and was comparable in size to Pluto. The discovery immediately created a difficult question. If Pluto was a planet, then Eris might also have to be called one, and Eris was only one of several newly discovered worlds, challenging the old definition. Astronomers suddenly faced an uncomfortable possibility. The solar system might not have 9 planets after all. It could have 12 or 20, or perhaps many more as telescopes discovered additional Pluto-like objects. The problem was no longer about Pluto alone. It was about classification. Science needed a definition capable of separating planets from the growing number of large bodies found throughout the solar system. And in 2006, the International Astronomical Union attempted to create one. But the definition that emerged would place Pluto in a completely new category. It was not rejected because it was too small. Pluto is massive enough for its own gravity to pull it into a nearly round shape. That matters because shape is one of the characteristics associated with planetary bodies. The real problem was something else, something about the space surrounding Pluto. According to the new definition, being round was not enough. Orbiting the Sun was not enough. To remain a planet, a world also had to do something much more demanding. It had to dominate its own orbital neighborhood, and that single requirement changed Pluto's place in the solar system forever. In 2006, the International Astronomical Union established 3 criteria for an object to be classified as a planet in the solar system. First, it must orbit the Sun. Pluto passes that test. Second, It must have enough mass for its own gravity to pull it into a nearly round shape. Pluto passes that test too. Then came the third requirement. The object must have cleared the neighborhood around its orbit, and Pluto fails this one. But what does that actually mean? It does not mean that Pluto travels through completely empty space. Instead, it refers to gravitational dominance. A major planet becomes the dominant gravitational object in its orbital region. Over the history of the solar system, a planet can absorb, eject, capture, or otherwise gravitationally control many of the smaller objects near its path. Earth, for example, is the dominant body in its orbital neighborhood. Pluto is not. It shares its distant region with countless other objects in the Kuiper Belt. Its orbit is also connected to Neptune through a stable orbital resonance, meaning their motions are gravitationally related in a way that prevents them from colliding, even though Pluto's orbit can bring it closer to the Sun than Neptune. Because Pluto has not cleared its orbital neighborhood, the International Astronomical Union placed it in the category of dwarf planets. This is where an important misunderstanding often begins. Pluto was not destroyed as a planet. Nothing happened to the physical world itself. No one discovered that Pluto was smaller than previously believed. No one found that it was an asteroid. Its reclassification was entirely about terminology. The IAU created a formal definition, and Pluto did not satisfy all three requirements. Officially, that is the reason. Pluto orbits the Sun. It is nearly round. But it has not cleared its orbital neighborhood. Case closed? Not quite. Because many scientists have never been completely satisfied with the third requirement. And that disagreement is the reason Pluto's planetary status remains one of the most famous debates in modern astronomy. The official classification of Pluto is clear. According to the International Astronomical Union, Pluto is a dwarf planet. But scientific agreement does not always mean scientific unanimity. Some planetary scientists have argued that the definition adopted in 2006 places too much emphasis on an object's orbit rather than on the physical nature of the object itself. From that perspective, Pluto has many characteristics associated with a complex planetary world. It is round. It has a layered structure. It has mountains, plains, glaciers, and a thin atmosphere. It has a complex system of moons. Its surface changes over time. To scientists who favor a geophysical definition, the question is not whether Pluto dominates its orbital neighborhood. The more important question is what Pluto actually is: a large, round, geologically complex world. That is why some scientists still use the word planet when discussing Pluto and similar bodies, even though the official IAU classification remains unchanged. The disagreement becomes even more interesting when we look at the logic behind the definition. The IAU definition is specifically designed for objects orbiting the Sun. It is a solar system definition based partly on the dynamical environment surrounding an object. But planetary scientists study worlds based on their physical properties as well. In other words, there are two different ways of thinking about the question. One asks, what role does this object play in its orbital environment? The other asks, what kind of world is this object physically? Pluto can produce different answers depending on which question you believe is more important. And there is another reason the debate continues. In 2006, scientists had never seen Pluto up close. The decision was based on what astronomers knew from Earth and from distant observations. But less than a decade later, a spacecraft would finally reveal Pluto in extraordinary detail. And what it found made the debate even more difficult to ignore, because the world at the edge of the solar system turned out to be far more complex than almost anyone had expected. On July 14, 2015, NASA's New Horizons spacecraft made history. After traveling for more than 9 years, it flew through the Pluto system and became the first spacecraft to explore Pluto up close. The images that returned to Earth changed the way scientists viewed this distant world. Before New Horizons, Pluto was little more than a blurry point of light. After New Horizons, it became a world. A real, complex landscape appeared on our screens. Pluto had enormous mountains made largely of water ice. It had vast plains covered with volatile ices. It had evidence of glacial flow. It had ancient cratered terrain. It had regions that appeared much younger than others. One of the most striking discoveries was Sputnik Planitia, a vast basin filled with nitrogen-rich ice. Studies of Pluto's geology showed evidence that some parts of its surface are shaped by processes that continue to move and reshape material. New Horizons did not restore Pluto's official planetary status. The spacecraft did not change the IAU definition, but it did something equally important. It made the debate more complicated. Pluto was no longer an abstract object defined mainly by its size and orbit. Scientists could now see a world with extraordinary geological diversity, a world with mountains and glaciers, a world with a complex relationship between its surface and atmosphere, a world that had preserved clues about the early solar system. And that leads directly back to the central question. If we encountered Pluto for the first time without knowing its name, would we look at this complex world and immediately say that it was too insignificant to be called a planet? Or would we judge it differently? New Horizons showed us that Pluto is not merely a small object at the edge of the solar system. Whatever label we choose, it is a fascinating planetary world in the broadest physical sense, and perhaps that is why its demotion remains so controversial. The more we learn about Pluto, the harder it becomes to reduce it to a simple category. So after everything we know today, what is the answer? Is Pluto still a planet? Officially, no. The International Astronomical Union has not changed its definition of a planet since 2006. Under that definition, Pluto is classified as a dwarf planet because it has not cleared its orbital neighborhood. But scientifically, the answer is more complicated. Pluto is a large, nearly round world. It has a complex geology. It has mountains, glaciers, plains, an atmosphere, and a system of moons. New Horizons revealed a place far more dynamic and diverse than the distant point of light astronomers once imagined. That is why the argument continues. The debate is not really about whether Pluto changed. It did not. The debate is about what the word planet should mean. Should a planet be defined by its physical characteristics? Or should its classification also depend on its gravitational dominance over the region around its orbit? The IAU chose the second approach. Other scientists continue to argue for the first, and perhaps that is what makes Pluto's story so fascinating. It reminds us that science does not simply collect answers. Sometimes, it must decide how to organize the answers it discovers. Pluto was once the 9th planet. Today, it is officially a dwarf planet. But the tiny world itself remains exactly where it has always been, more than 5.8 billion kilometers from Earth on average, traveling through the darkness beyond Neptune, carrying secrets about the outer solar system that we are still trying to understand. Maybe Pluto did not really lose its place in the solar system. Maybe we simply changed the name of the place it occupies. And that leaves one final question. If you could rewrite the definition today, would you make Pluto a planet again? Leave your answer in the comments. And if you enjoy exploring the biggest questions in space, subscribe to PointView. Because sometimes the most fascinating discoveries are not about what we find in the universe. They are about how we choose to understand it.